Now, for the next talk, I would like to invite Harsh Thakur to talk on first principles of observability systems, where he'll look at how various open source projects have tackled observability problems for him. Over to you, Harsh.
Hey folks, thanks for showing up. I know it's been a long day and this is the last talk. Um, my name is Harsh and I work as a developer at Civo, where I help develop operators and API services that power cloud infrastructure services like managed Kubernetes, object store load balance and whatnot. And today's talk is about first principality of observability. I'll get right into it. I'm sure you folks have all had conversations around various log formats you should be using, what kind of log retention your log should have, and just debates about which logger is the best. Um, so I want to take it a step back and talk about a time before I was born, um, where systems used to log on a single host. Everything was simple. Linux search utilities work really great because there was less volume to deal with. So everything was happy. And at some point, we had this evolution of using containers, microservices, essentially various data sources for logs to come from. And we started to realize that simple Linux utilities didn't work because there's the huge volume of data to deal with. So we were pretty convinced at some point that logs are a search problem. And essentially, we came with this observability pipeline, which is not just related to logs, but any observability data, that we have the apps, and we have an ingestion pipeline. Either we are pull or a push method. Apps get this data into the ingestion pipeline, after which it's stored in a data store. And this data store itself could have a query layer. And this data store could be something like object store or Hive or OLAP database. It doesn't really matter. And after that, we have a dashboarding or an analytic solution on top of this query layer. And I'm sure you all have used some sort of the stack, and you can relate with this. And around the time of 2012, since everyone was convinced that this is a search problem, the story goes that there was an open source version of a search engine called Lucene, and someone was working on to make a distributed version of it, high availability and sharding and whatnot. So, and someone else was working on log aggregation and pushing it in the ingestion pipeline and getting it into the data store. And there was someone else who was working on a dashboarding solution. And all these three folks at some point decided that they should just make a stack out of this and create a company out of it. And that's what they did. And a lot of people adopted it. I'm sure you all have heard of ELK stack. But companies have started moving away from it after they hit certain scale. So why? There must be a reason, right? So they realized that it's expensive and it's hard to operate. It's expensive because it does something known as indexing, which if you do more of it, it uses RAM, so it gets expensive. And as Michael Scott would say, more money, more problems. So what is this indexing thing? So any text-based problem which requires searching, this concept of inverted indexing, where in our case, let's assume documents are log files. During ingestion, we just find each word, note it down in memory, and find all the log files it could possibly be in. So we create this map and store it in memory. And there are benefits to it because we can quickly find out where these words are coming from. So this leads to faster queries. But the downside is it slows down the ingestion rate because we have to keep making this map. It's also directly proportional to memory usage, hence higher costs. So a lot of these companies decided that they need to move away from ELK and they started making alternative projects or alternative stacks based on what they learned. So I'm quickly going to explore all like a bunch of what other companies have done, and then we can evaluate what common patterns we see from all these companies or projects. So let's start with Loki. How many of you use Loki over here, or have used Loki at some point? So, so maintainers of Loki were very keen on going the other way of this. They realized that logs are not a search problem, so they decided they shouldn't index any data. So they decided only to index the metadata and store all the files in object store, which is the cheapest scale-out storage you can find, which is really neat and works for small to mid enterprise. Like up until a certain scale, it works really great because there's no indexing issue like we saw with ELK. And they have a pattern where this object files are stored with gzip compression, so it's really good compression rate at the cost of high CPU cycles. And the way they store it is with something known as BoldDB in the recent architecture, where BoldDB stores this index metadata, and the map is just there to the which files this could be in. And those indexes are essentially what all metadata this could be in. So they also have a custom query language which is inspired from PromQL, which is LogQL, which is fairly easy to grasp. But there are limitations to Loki as well, and a couple of companies have benchmarked it, and it didn't work for them for the following reasons. Because not indexing anything is also sort of not a good, great solution for certain cases, because queries tend to be slow when there's nothing being indexed. And also, apparently, Loki's RBAC support is very limited in OSS version. And since it's HGPL, certain business policies don't allow a software to be used. So I'm going to run through a bunch of companies that have used ClickHouse as an alternative data store. I'll get into what ClickHouse is and whatnot in a bit. But essentially, think of it as an analytical database where it's well suited for storing time series data. And these companies, starting with Uber, they use Kafka as an ingestion pipeline, store it into ClickHouse. They have done something very interesting, which is dynamic indexing. So what they do is they don't index any data by default. So that means really high ingestion throughput, which is great for writes. And then they only index the data based on query patterns. So only the frequently queried data is indexed, which is sort of the best you can get out of both worlds, where we saw with ELK not indexing everything, and then Loki not indexing anything. This is a very dynamic way to solve the problem. And also the data is compressed with LZ4 and ZTSD. These don't provide compression as well as gzip, but they take less CPU cycles. So it's a trade-off between storage and high CPU cycles. And based on what suits your needs, you can choose. So having that option is really good. So Kafka has done something similar to what we just saw with Uber. The only difference is they didn't do any sort of dynamic indexing. They just did it based on timestamp and host name. And during ingestion, they downsample the data. Essentially, they have a high resolution tables where they store data in 15 minutes, half an hour, and 1 hour table. So if a query comes for 15 minutes table, they just send the query to the 15-minute table. And they also have LZ4 compression. The other thing to note here is instead of using inverted indexes for the data itself, they've used Bloom filters. N-grams Bloom filter, which is a decent way to know if a certain word doesn't exist in the logs. It's not as good as inverted indexing, but it's a good start. Zerodha has also done something similar, and they have a really good blog post about it. I have all the links in the presentation. They also have done something very similar, except they used Vector instead of Kafka as a project to ingest the data, and then Metabase to query it. They also created their own query language, which is very similar to LogQL. eBay, from what I've seen in the blog post, they have done a lot of indexing, but they have done something similar to what Cloudflare had done with having multiple tables on top of existing existing table. This is to fasten the query speeds, and they use more ClickHouse native way of using materialized views and whatnot. But I recently learned through a YouTube podcast from one of their engineers that they have changed it a lot more, so this might be way outdated. There's also an open source project called Signox, which does minimal indexing, and it does for logs, traces, and metrics. And they also use Bloom filters. It's a very good startup project, which is actually open source, unlike the previous alternatives we discussed. The query layer is direct ClickHouse SQL, so you don't have any sweet sugar like LogQL on top of it just yet. Another company to discuss here, which is very interesting, is Netflix. They don't use ClickHouse for a change. But what they have done is very interesting to me because they decided not to store any data by default. Like no log data is stored. And they only store the data when developers explicitly go to a portal and mention that some data needs to be stored. So they don't pay the cost of storing all the data. That is one way to go about it. And then they have a mix of indexing the data. So they store all the metadata inside Cassandra for time filtering. And then they index a limited amount of data for limited amount of time in Elasticsearch. And then after that time period has passed, they store it in Hive, and then they process it, which is very similar to what Loki's BoldDB indexing does. And it's SQL dialect from what I see in their blog post. So from all these case studies, it's one thing that's like these are the things that are common. Like first thing is indexing. Right amount of data needs to be indexed. Otherwise, you run into paying higher cost than you need to, or having low performance than you really need. And type of indexing also matters. So having fully inverted indexes or Bloom filters, or the time filtering, like what kind of indexing we do, will actually decide if we get the performance we want or not. Storage-wise, columnar files and block formats are really preferable because, just like any OLAP database would solve this problem, because columnar, we sort the data while insertion. It gets us high speed while reading. So the next thing is Codex. So elevator pitch for Codex is, let's imagine we have a bunch of data which is in multiples of 10, like 10, 20, 30, 40. So a delta codec would only store the difference between them. That reduces the amount of data in bytes that needs to be stored because there's only the delta of it. And then we compress the data with algorithms like gzip, LZ4, and ZTSD. So there's even less data stored. And then when we have that support integrated with something like object store, it gets even cheaper because object store is cheap. So another aspect is correlating this data. So correlation of data is really important because sometimes we want to correlate metrics. We need a debug journey, right? We need to go from alerts to metrics, metrics to traces, and traces to logs. So that having that journey is important in terms of solving a problem. And then there are use cases where you might need to correlate existing observability data with business data. And this is a new pattern a lot of the companies are seeing, and which has led to interesting projects like Timescale DB as well. So we've seen ClickHouse used by a bunch of companies. So why does it seem like a popular choice these days? It's a generic OLAP database, so it's very well suited for time series data. It has all the codecs and compression algorithms that suit observability needs. It has storage retention policies that allow you to do HDD to SSD to object store. So you have layers of data you can tier based on time periods. It has SQL-like syntax, so a lot of people are familiar with it. And then it has data skipping indexes, which we briefly talked about, where you have Bloom filters and inverted indexes. And recently, they also added support for it as alpha, and it has some good performance at the cost of indexing, of course. So we need to be careful how much we index in this case. It also scales vertically really well, and horizontally it scales, but it's not automated yet, so it requires some operational expertise. But I've talked to certain observability vendors who have been doing it happily, and it works well for them. So the next thing is you can query any data source out there, like popular data sources like MySQL or Postgres tables, which you have in some other servers, through ClickHouse, and correlate that data with your existing observability data. So this can be useful for having that cross-server compatibility. It's also good for multi-tenancy because there are a lot of good features ClickHouse has, like row-level policies and query limiting. But what about metrics and traces? I realized later after I submitted the talk that this was a 15-minute talk, so I couldn't get much into it. But essentially, there's a really nice talk from Victoria Metrics maintainer that ClickHouse was an inspiration for Victoria Metrics, and it lacked certain features 5 years ago. But all those features actually exist today. So it's a really interesting thing to see that Victoria Metrics probably wouldn't have been needed if ClickHouse had those features 5 years ago. There's also a really good blog post from ClickHouse maintainers on how they suggest tracing should be solved. So it's all good. The last thing I want to touch upon is industry standardization on observability. So OpenTelemetry has been like the second most contributed project in CNCF landscape after Kubernetes. A lot of observability vendors have started to adopt it and push it down to end users. So app instrumentation with OpenTelemetry has become the default for greenfield projects. Also, the transport protocol is gaining traction and is supposed to be the de facto very soon. The next thing which I'm really excited about is query standards. So it has been recently started, and the working group has been just allocated to do this work under CNCF. And what they aim to do is have a single query language for all kinds of observability data. So like any single language for querying your logs, metrics, and traces. So which is really cool because you wouldn't have to change your alerting or dashboarding solutions even if you switch vendors. So if both the ends are solved for, and we have industry standards, maybe ClickHouse can be the standard at some point for storage as well, because that seems to be the only thing right now that people are debating over based on the various needs. And ClickHouse seems to have all the fundamental properties to support the varied behavior people want. That's it. Thank you. Happy to accept any questions.
Okay. Thank you, Harsh, for giving a wonderful talk on observability and ClickHouse. Now I would like to request Vinuja to felicitate Yash. Sorry, Harsh.